So this question is maximum power transfer question. So most of the people like will do mistakes in this kind of question. Like what we have studied, like in maximum power transfer theorem, if it will be a resistance. So this if this load will be resistance, only resistance, so R should be equal to RTH. Okay. And if this will be a load will be a R plus JX. No. If this side it will be a complex value. If 1 second. If let's say circuit will be like this, R JX, and here variable resistance will be there. In that case, what will be the RTH? RTH will be this magnitude of this impedance. So it will be under root R square plus X square. Okay. This will be the two case. But here this is the third case, like where this load itself is not variable. Here this resistance is given as constant and this inductor is given constant. What is the variable function here? It is a capacitor. So one concept we have to apply in any type of question, like if any load will be a R plus JX. So for maximum power transfer, this X part should be 0. If this X will be 0, in that case, maximum power transfer will happen. Okay. So here, this is a variable capacitor. So the value of the capacitor should be such that the whole impedance should be resistive. Okay. So how we can calculate? So already omega value is given. Okay. So I'm going to equivalent impedance of this part. So 1 ohm into minus j by omega c plus 1 minus j by omega c. So it will be 1 into minus j by 100 c divided by 1 minus j by 100 c. So it will be minus j by 100 c minus j. So this we can multiply 100 c plus j and here 100 c minus j. So it will be 100 c square plus 1. So it will be minus j into 100 c plus j divided by 100 c square minus j. And this will be omega L. So omega is 100. So it will be plus j. This will be 0.5. So this will be the total impedance of the load. So for maximum power transfer, what is the condition? If like impedance will be a complex impedance and any part will be variable, either L or C. So in that case, it should be
Conjugate.
purely resistive. Then only it will draw maximum power. Okay. So what will be the condition? If
Conjugate. Sir,
yes.
conjugate to which case?
See, conjugate will be applied only when this kind of condition will be there. Okay. Let's say circuit will be like this. This is the source and this is R plus JX. Okay. And we have to calculate Thevenin's resistance. So Thevenin's resistance will be this. And if impedance will be R plus JX. Okay.
Means the
In
load should be R plus JX.
see if it will be resistive, okay, then it will be magnitude of this one. Okay. If it will be R plus JX, then it will be a complex conjugate. So complex conjugate means what is happening? In that case, this reactive part and reactive part is cancelling each out. So it means our network is purely resistive. Okay. So in that case, maximum power transfer will happen. Now the third case. So overall, what we have to do, we have to make this whole network purely resistive. Okay. I will explain once more. Let's say this is the case. I will
And
write all case I will write. Okay. So
इस केस
first,
में भी तो वही हो रहा है.
okay, all case I will write. Let's say this is first case. Only R and this is RTH. So RTH is equal to R. Second case R plus JX and this will be R. So R will be mod Z. Third case R J. So this will be complex impedance, and load also will be complex, R plus jx. So this is R plus jx. So these both are complex. So in that case, this reactive part should be equal to this reactive part. Okay. So it will make this whole network resistive. But here the case is different. Here this is only resistive, but our load is R plus jx. Okay. Our load is R plus jx. So for maximum power transfer to the load, the reactive part of load should be 0. Is it clear? This will be the concept.
Yes, yes.
Okay. So from this equation, we can calculate the value of the C. So reactive part
Sir,
of, yes, you can ask.
in Z have you added inductance?
Where? See here, J 0.5. So total Z I'm going to write. Z will be J 0.5 plus this part minus J into 100 C plus J minus J into 100 C plus J divided by 100 C square minus, this will be A plus B, A minus B, so it will be plus 1. This will be 100 C square plus 1. 100 C minus J into 100 C plus J. So it will be A square minus B square, so it will be 100 C whole square plus 1. So this will be 100 C whole square plus 1. This will be the total impedance. So what will the reactive part? Reactive part will be J 0.5 minus J.
Sir, while calculating resonance, this is the same case.
Similar, we can say similar.
While
See,
calculating the resonance
at
frequency, or
yes, resonance only we can say. Reactive part means 0 means the load will be purely resistive load. Okay.
the
In max,
resonance, in the case of resonance, same thing happened
same
with
thing.
imaginary part 0.
Yes, yes, yes. Resonance also imaginary part will be 0. For maximum power transfer theorem, 2-3 varieties of question will be there. One will be this, one will be this, and if this will be there, so it will be Z conjugate. Okay, you can derive this. Why this is at like if we are doing this, like variable capacitance is there at value of when this reactive part will be 0, then only why it is drawing maximum power, that you can verify. Okay. For this also derivation will be there in some book. Why? Why if network is purely resistive, then only it is drawing maximum power.
Maximum power, yes.
So that will be the condition. If it will be purely resistive, this load will be purely resistive, then it will draw the maximum power.
Then it also the case of resonance.
Similar. It is also the case of resonance. Resonance means that part, reactive part will be 0.
0.
Okay. So from here we can calculate the C value. 1 second. So this reactive part should be 0. This should be 0. So we can write 0.5. This should be equal to 100 C divided by 100 C square plus 1. So this will be 10 to the power 4 into C square. This will be 2000. How much? 1 second. 200. Second. This is 0.5 or 0.05. 5 milli. So 5 milli into 100 will be 0.5 only. And this will be 100 into minus j. Okay. So 10 to the power 4 into c square plus 1 minus this will be 0.5. So it will be 200 c equal to 0. So this will be the quadratic equation. Okay. This one we can write as 10 to the power 4 c square minus 100 c minus 100 c plus 1 equal to 0. So here also we can take common. 100 C will take common. So 100 C minus 1. Again it will be minus. So what will be the value? C will be 1 by 100.
10 millifarad. 10 millifarad.
So answer will be D.
10 millifarad.
So these four concepts you should memorize. Whenever this type of question will come, either L or L also they can give variable. If any combination of network will be there, okay, L or C. So we have to make the load purely resistive. Accordingly, we can calculate the either L or C value. Is it clear to all? Can I move to the next question?
Sir, load resistive or the
Yes,
whole
sir.
circuit will be resistive?
See, here this load is this part. Okay. That circuit should be resistive. That's why in this case, Z should be equal to Z conjugate because here this part already complex. Okay.
Circuit should be resistive.
Circuit should be resistive.
Ah,
But here, why I have applied like that? It's because here it is purely resistive. Okay.
hmm.
That's why. If it will be like this one, R plus JX here, so
Then conjugate.
this should be such that it should be conjugate of this one.
Ah, ah.
Okay. But here only resistance was there. That's why I made it resistive, only load.
Okay. Okay.
Up. So we can say that this is also same. Like here also we are doing same thing. We are making resistive circuit just by making it a conjugate R minus JX. Okay. Should I move to the next question?
Hmm.
Okay. So this is I think 2022 gate question. 2022 or 2021 maybe. Simple only. So already this resistance is given, voltage source sin t, so frequency will be 1, and this is the current. Okay. So what will be the current equation? I of t will be sin t divided by 1 plus z. Okay. So from waveform only we can see what is the magnitude here? 1 by root 2. Okay. So either it 1 by root 2 means this 1 plus 1 square, and so either it will be 1 Henry or 1 Farad capacitor. In this we have to choose the option. One of the option will be correct. So see here we can see that at t is equal to pi by 4. T is equal to pi by 4. The value is 0. So what we can say that sin t minus pi by 4. The value of it we can write like this. Is it clear?
In the current lags voltage by an
Yes.
angle of
So
45 degrees.
Like
so we can say that this will be the
inductor.
inductor, like
Inductor
1 by 1 plus 1 0. This will be the answer. Think it is clear to all?
Yes.
Okay. Okay. Moving to the next question. Now, this is also easy question only. Should I solve first synchronous machine question? Then I will come back to this question.
Okay, sir.
Okay. Okay. So this is the first question from synchronous machine I have taken. So before solving any synchronous machine, first we should see one thing, like whether either machine is in delta configuration or a star configuration. This is the first thing we should see. Okay. And this is what given synchronous motor. So motor or generator, what should be our first step? We should draw first single line diagram. Okay. So this is synchronous motor is given, and it is a star or delta, it is given a star connected. So this first should we should tick mark. Okay. So I'm going to draw the equivalent circuit. So this is a bus bar, and here reactance will be given Jx. This will be V angle 0, E angle minus delta. So our first step should be this. First we should draw this single line diagram. And if delta will be there, in that case, phase voltage and line voltage will be same. And while we are writing any KVL equation, in that case, the given voltage we can select. But in case of a star, so in question, whatever the voltage will be given, mostly it will be line to line. Here also we should be careful. In question, three phase data will be given. If nothing will be mentioned, so voltage will be line to line. And if it will be mentioned that phase voltage is given, then we should be careful at that point also. So first In case of a star, if we are writing any KVL KCL equation, first we should convert the line voltage into the phase voltage. So how we can convert? V phase will be equal to V divided by V line to line divided by √3. So this point we should take care. Like in case of a star, V phase we will calculate by V line to line divided by √3, and in delta, no need to convert. We can write any KVL KCL equation by using that voltage only. Like delta circuit will be like this. This is the EMF, okay, and like this it will be there. So across these 2 points, line voltage will be there. Okay. So if we are writing KVL in this type of circuit, directly we can use line to line voltage. Okay. So here, since a star circuit is given, so what will be the phase voltage? Phase voltage will be 11 kV divided by √3 angle 0. Okay, this will be the phase voltage. So in question, what it is given, like synchronous reactance is 50 ohm, so it will be J50. Okay, and a stator resistance is negligible, R will be 0. So first statement they have written that the motor has a constant field excitation, so E will be constant. Okay, constant field excitation at a particular load torque. The stator current is 100 ampere at unity power factor. Okay, so I'm going to write the simple phasor diagram. So here we can write it V angle 0 minus IA into JX should be equal to E angle minus delta. So this we can write as a phasor. So V I am taking as a reference. Okay, so V will be the reference. This is V angle 0, and this is E at angle minus delta. And unity power factor means current will be in the phase of the voltage. So this will be the IA summation here. So V will be E plus IAXX. V will be equal to E plus IAXX. So this is the direction of current. So what will be the IAXX direction? It will be like this. So it will be IAXX. So this is a phasor for first condition. V I have taken a reference. E is lagging by delta, and IA axis will come perpendicular to this one. So this is a right angle triangle. Is it clear to all this phasor diagram?
Yes, sir.
Okay. Okay. So from this condition, already this V value is given, IA value is given, and XS is given. So V is how much? 11,000 by √3. IA XS. So IA in this condition is 100 ampere and XS is 50. So IA XS will be 50 into 100, so it will be 5,000. Okay. So this E value we can calculate from this right angle triangle. What will be the value? So E square, E will be equal to under root V square plus IA XS square. So this will be the value of the E. Is it clear? So how to solve this with Calci? I'm going to show. So IA access how much? 50,000. So 5,000. So 5,000 a square. So square will click this one. This will put in memory save. So we can see here if we will click MR, this value will be saved. Okay. Again 11,000. So 11,000 divided by under root 3. So this 6350, again a square of this, plus already we have saved one value memory, that IA access square, plus this 2 we have added, again the square root of this one. So this value will be 8082. Okay. So E value will be, E will be equal to, E is equal to 11,000 by √3 whole square plus 5,000 whole square. So any you can do calculation like 11,000 by √3 whole square. Memory you can save this one. Again you can do this square and plus memory and under root. So it will be 8082.9. 8082.9. So this will be the value of E. This is condition 1. Again, what it is saying in the question, if load torque is increased so that the stator current is 120 degree and the load angle in degree. So here the EMF is constant. E is constant. So if we'll increase the load, what will by increase delta value will increase. Okay. So again I'm going to draw the phasor. This is V angle 0. So E will be constant. Since excitation is constant, E will be constant. What is the equation? P is equal to EV by X into sine del. So since load is increasing, E is constant, V is constant, X is constant. So what will happen? Delta will increase. Okay. So this is the first case. It was like this. So this is the magnitude of the E up to here. So this will increase on this circle only. EMF magnitude will be same. So let's say it will be here somewhere. Okay. And this will be IA into XS. Okay. This will be the phasor in second case. Delta will increase. Since load torque is increasing, delta will increase, but E magnitude will be same and V magnitude will be same. Okay. Is this phasor is clear to all? Case 2. IA will be
Sir,
120 ampere. Case 2, we are
hello.
increasing the load. Yes, you can ask.
Sir, in this phasor diagram, IA in phase of Vy, it is resistive
See,
load.
no, it is asking that unity power factor. See, first case you read here. The motor has a constant excitation at a particular load torque. Its stator current is 100 ampere at unity power factor. So this is the stator current. Okay, 100 ampere. But unity power factor means this terminal voltage and this current will be in phase. Okay. Is it clear? This is the stator current. This is the terminal voltage of the
Yes,
motor.
sir.
So unity power factor means this voltage and current will be in same phase. Okay.
Sir, in case of motor, E is lagging YV, and in case of generator, it is leading YV, Y delta.
Yes, it will be opposite because see, this is in case of alternator, it is supplying, and in case of motor, it is drawing the power. So we are taking the reference this. If this will be reference, this voltage will be lag this terminal voltage. Okay.
Okay.
Is it clear?
Yes, sir.
Okay. So second case phasor is clear to all. See, E will be constant. Already told in the question, excitation is constant. So magnitude of this EMF will be constant. Okay. We are increasing the load torque. So load torque increasing means P increasing, and P increasing means delta will increase. So delta will increase in this direction. Okay. But E magnitude will be same and V magnitude will be same. And IA in the second case is 120 ampere. So this diagram is clear to all? Phasor diagram, is it clear? Case 2 diagram.
Sir, Y is constant and V is
See,
constant.
see, V is terminal voltage. In question already given that terminal voltage is constant. Okay. V means we are supplying 11 kV rated voltage. See, at particular load torque, stator is doing at unity power factor. If load torque is increased, the stator current is 120 ampere, then the load angle. At this case, we have to calculate the load angle. Okay. So here somewhere it is mentioned the motor has a constant field excitation. Okay. So EMF in any machine, EMF is proportional to DC excitation, field current. If this will be constant, the EMF will be constant. Like we have already studied synchronous machine. So in these two windings will be there. A rotor winding will have a constant DC excitation. DC supply we will give here. And this stator will have a three phase 120 degree place displace and time displace supply. So since this is supply is constant, this EMF excitation will be constant. Is it clear? We have not studied synchronous machine like previously.
Yes, sir. Clear, sir.
Okay. So since E is constant, here I have taken same value. So previously already we have calculated E value. How much? 8082.9. So how we can calculate in this type of question E value? Okay. So this is a triangle. This magnitude we know, this magnitude we know, and this magnitude we know. So cosine law we can write as IAXS whole square is equal to E square plus V square minus 2 EV cos del. This is cosine law. Like ABC, this is ABC. So C square is equal to B square plus A square minus 2AB cos this value between A and B. So here this is the cosine law. Already we have studied in 12 this formula. So same thing we can apply here. This square is equal to V square plus C square minus 2EB into cos del. Okay. So IAXS what will be in this case? 120 into 50 whole square is equal to E how much? 8082.9. 8082.9 square plus 11,000 by root 3 whole square minus 2 into 11,000 divided by root 3 into E how much? 8082.9 into cos del. So from this equation we can calculate the value of delta. Okay. So how we can do this with
Sir, please repeat this IA access whole square E square B square.
Okay. So in any triangle, let's say this is triangle. Okay. This section is A, this is B, this is C. Okay. And this is angle C. Angle C. Across. So what is the cosine law? Cosine law is equal to C square is equal to B square plus A square minus 2AB into cos C. Okay, this is the cosine law, trigonometry. So this is a triangle. This length is IAXS. Okay, this length is V. This length is E. So IAXS whole square is equal to this square plus this square minus 2 into this into cos delta. This is called as cosine law. Okay, you can search on Google. This is cosine law. So this triangle already we have. With the help of cosine law, we can write this equation and calculate the value of delta. This only is asked in the question. Is it clear? This we should memorize, this formula. Is it clear to us?
So while finding E,
Yes.
if for finding E, which formula you used?
See, for finding E, first case I have used. So first case what they have given?
Equation. Yes, sir. Yes.
First case they have given.
Clear.
Okay. So this we can how to write in the virtual calculator. Okay, step by step we can do this one. Like see, this square minus this square minus this square. So first how we can do this two part we can save in the memory. Then this square minus this. Okay. First this two part we will save in the memory. Okay. Then this like this minus this we can do. Okay. So I'm going to do that. 8082.9 11,000 by root 3 square. So 8082.9 square. So this we will save in memory. Okay, and second 8082 second 8082.9 square. We can say memory. Again 11.
Sir, 1 minute, sir. For saving memory, we are clicking MS, sir.
Yes, MS, memory save. You can
What
check
about
that.
MR, sir?
Here we can check that value, whatever we have saved.
MR.
Yes, memory read.
Okay.
Memory save, memory read, I think. So this is the value. Again, 11,000 by root 3. This one whole square plus memory. So again I am doing this memory save. So what I have done till now, I have saved this first two parts 8082.9 square plus 11,000 by root 3 whole square. Now from this we have to subtract this. Okay. So I am doing this minus this and multiply by minus 1. So that will be the part. Like from this minus this and
Sir,
this part. Yes.
hello. So
And
while calculating from the formula, V with an angle 0 is equal to E with an angle delta plus IF with an angle phi, ZS means the formula which you have written.
yes,
Uh, if from that it can't be possible to solve. Means EG from while putting all the values, EG can be calculated from here. It is coming as same.
which ones can be calculated?
Means while putting V with an angle 0 is equal to EG with an angle minus delta, the previous one which we have written,
Okay, this one.
this one, from here we get the EG, okay?
Yes, E
And
value.
E value can be calculated. If
Yes,
it is written that load torque is increased, so the delta angle will change.
yes.
And again, while writing this formula, in putting in this formula, not using that cosine law, is it possible to solve?
See, next case is not like, if next case also will be unity power factor. Okay.
Means the unit power factor angle is
See,
not given here.
yes,
Only
next case if power factor will be given, then also like, see here why it is easy. If this kind of condition will be there, directly we can calculate delta. Delta for first case directly we can calculate tan inverse this by this. But second case, delta is increased, and this is not a right angle triangle. That is a right angle triangle. How it is forming? Because this is in phase, so this axis will be perpendicular, IA into XS, J times. But here it is not a right angle triangle. Okay.
Miss, I am putting in the formula. Suppose I put in a formula, the same formula, previous one.
This one.
Here it is power factor angle is
This
not given. Power
see
factor
this
angle.
delta we can calculate this for first case. First case we can calculate
Uh,
from here. Okay.
it
But
is coming
second
as
case, what it is saying, load current is increased 120 and the angle is increased. So this will come here somewhat, like on this circle only. This will come here.
yes,
So
yes. My
this will
question is from here. What delta angle is calculated
okay.
from here? Delta angle is coming 36.18.
Okay. First case.
In
Okay.
first case. So second case we have to when the load is changing, so we need to calculate delta again. Okay.
Yes. Yes.
So for the delta again, the power factor angle is not given.
Yes.
So
So this is the only, whatever the information is given. This is only way we can calculate the delta with that given information.
so we can't take delta unity again
See, power factor will
in the
not be
second case.
power factor will not be unity, because see, this is the current direction. So current and IA axis will be always perpendicular. So this will be the current.
Okay.
This is the IA axis. So current will be somewhere this, and this will be lagging in nature. Is it
Okay.
clear? See, this is
Uh,
IA axis.
okay.
In previous case it was perpendicular because this was in phase, so it will be like this 90 degree. But here,
Okay.
since this is going like this current will be perpendicular to this J axis, so this will lag by some phase angle phi.
And this why we don't know.
We don't know. So this is only cosine law only we can apply.
Okay.
Is it clear? Further, I'm going to calculate it. So 120 into 50 square. Okay. So 120 into 50, this whole square, minus this value. So this will come negative. So into minus 1. 0 minus 1. So this is the total value. Okay. This is the total value. So what we can do, we can divide it by this total. So how we can do? First multiply all three, 11,000 by root 3 into 8082.9 into 2, inverse it and multiply. Okay. So 8082.9 8082.9 into 11,000 into 2 divided by root 3. So inverse it and multiply with memory. So this will be the value. This will take cos inverse. So cos inverse I have taken. How much I am getting? 47.26. Is it visible to all? Calculator values. Is it visible? Anyone can reply?
Yes,
Yes,
Yes, sir,
sir.
visible.
See, so this is the
47.26.
47.26 delta value, 47.26. So like this we should do. Directly if you put all bracket, then chances of error will be there. So how I have done, again I will explain. First I have calculated these two part. First I have saved this, then I have calculated this and then saved this. So these two part is saved in memory. Again this minus this multiplied by -1. So it will be, this will be this side and this will be this side. Again we saved all value and then multiply all these three, take the inverse of this and multiply with the resultant, then take cos inverse. It will be the final answer. But here one more information is here. Since delta we are getting 47.26, but we have to careful. This is a motor. Okay. So in case of motor, delta will be negative. So load angle they are asking me, what will the final answer? Final answer will be minus 47.26. Here we have to be careful. For motor, if we are calculating delta, if magnitude of the load angle that it will be asking, then we can write 47.26. But here what it is asking, load angle in degree. So it will be negative. This is a fill in the blanks type question. So answer will be minus 47.26. Is it clear to all?
Sir, why loading is negative?
See, in case of motor, angle always will be represented as negative. Okay, because that is lagging the reference value. This is reference, like this is the reference in case of motor. So this excitation EMF will always lag the this reference value. So load angle, if it will be asking, so load angle will be minus always. So load angle, how much this is minus 47.26. This is the load angle. Okay, this is the reference. This is the excitation EMF. So it is lagging by 47.26. So what will be load angle? If it will be asked, you will write minus 47.26. Is it clear?
Yes, sir.
Okay. Okay. So I'm moving to the next question. Anyone have a doubt in this all explanation? Is it easy? Like easy way we can. Uh,
Click నాకైతే మొన్న
uh,
ఖచ్చితంగా చెక్ చేద్దాం
yes.
yes, sir.
అదే
Yes, sir. Yes, sir.
Okay.
This one is a good concept. Cosine triangle.
Cosine law we should remember. Okay. Someone is playing music. Okay. Okay. So moving to the next question. This is easy only. So I'm going to write some formula that you can derive also. So E is equal to, this is motor. So for generator I'm going to write for V plus IARA whole square plus V, here it will be V cos phi.
Cos phi.
Here it will be V sin phi
Sine phi.
plus minus IA x's whole square. So how we can memorize this formula? So for generator here it will be plus, okay, and here it will be plus minus. So plus for lag, minus for lead. This is for generator, okay. And same formula we can write for motor. So E will be equal to V cos phi minus IRA whole square plus V sin phi plus minus IA axis whole square. So in this case, plus will be for lead, minus will be for lag. So like this we can memorize. Here first part, for generator it will be plus, motor will be minus. Here plus minus will be there, but for generator lagging will be plus, leading will be minus, and in case of motor, this will be plus for lead and minus for lag. I think all of you know this formula.
Yes, sir.
Okay. Okay. So
Just
as
reverse of generator.
yes, that will be reverse. So first step in case of synchronous machine question, what we will see? We will see a star or delta. So here this is a star connected. So in case of a star connected, what we will do? First we will calculate the phase voltage. Okay. So whatever the voltage given in the question, that will be line voltage. So V phase will be 220 by root 3. This will be the phase voltage. Okay. And this information is given. 10 ampere rated current is drawing and power factor is 0.8 leading. So RMS value of the line to line voltage. Okay. So how we can calculate the phase voltage first? Phase, like first we'll write this single line diagram. So this is alternator, E angle delta. This is R plus JX, and this will be V angle 0. Okay. R plus JX. So same formula we can apply. E is equal to V cos phi minus IARA whole square plus V sin phi. Then this will be here plus plus for lead. Here it is leading, so plus IA XS whole square.
Sir, hello, sir.
Yes.
Sir, I have one doubt, sir.
Here it
Can you write E equal to V plus
so here I have done
IA
mistake.
into R plus JX, sir?
Yes, this is motor, so it will be reverse. You can ask again.
Sir, can you write E equal to V plus IA into ZS?
E is equal to, see, V minus, this is for motor. Okay, V minus ISZS should be equal to E.
Can you find out
So
with the help of this formula, sir?
V is equal
Line
to E plus IA into ZS. Like this also we can write.
Now here we know that V value, sir, phase value 220
Okay.
by root 3.
Same thing it will come here also. See.
We know that IA and also ZS also we know that, sir.
ZS also we know that.
Can you calculate with the help of this formula, sir? V equal to E plus IA. V equal to E plus IA into ZS. With this formula, we can calculate.
But sir, this formula is valid with an angle.
That will be lengthy. See, power factor angle also we have to add here. Okay.
Yes, sir. Yes, sir. Yes, sir. We can add, sir.
That we can calculate, but this will be lengthy method.
But that sir, this
more
will
complex
have angle also.
More complex calculation will be there.
Okay.
E with an angle minus delta.
E also we have to provide. How we can calculate angle? Like,
yes, sir.
E should be at angle like delta, minus delta.
Minus delta.
We can do, but this will be a like lengthy method. You can do with this also. Like if we have scientific calculator, we can solve in this way. But these short tricks we should remember for this.
And sir, one more question. Hello.
Yes, yes. You can ask.
Sir, while calculating the power in motor, we have to multiply. This means from here we get the I conjugate. Okay.
Okay. Yes.
V into I conjugate. Okay.
Yes.
So for the active power, we have to multiply with in motor V with an angle 0 or E with an angle minus delta.
Okay. 1 second. So
there's always confusion about.
Okay. I will explain. So in case of motor only you are asking. Let's say this
both motor generators both.
Okay. First I will explain motor. V angle 0. Okay. And let's say this is E angle minus delta. This is I. Okay. So if this resistive part will not be there, okay, only Jx. Okay. So what will be the P value? P will be EB by X sin delta. Yes. So anywhere if we'll calculate, here also if we'll calculate, it will be same only at this. So what will be the complex power here? S will be, we can calculate S here and S here. Okay. S you can calculate here or here at this point. So here if we'll calculating S will be V angle 0 into I conjugate. Okay. Here also if we'll calculating S, so it will be E angle minus delta into I conjugate. In both cases we will get P value same, but reactive component will be different. Okay.
But because this, sir, but suppose in that case V is equal to E plus ISZS, means it depends on the question what type of power they are asking. means generally we calculate for the motor by multiplying V with an angle 0.
No, see, we have to calculate with respect to point. Let's say here this kind of system is given. Okay, here they have connected something. Then we have to calculate the power, complex power here. At the with respect to
In one of your lecture, you have multiplied with E with an angle minus delta.
anything we can do. Anything we can do as per our comfortable. Okay, no need to memorize anything. In that
Yes,
lecture, I have
but
discussed something maybe like no need to memorize. You just like S is equal to VI conjugate at any point.
so
So here,
only the confusion is whether we have to multiply with V with an angle
see,
0 or
again
E
I'm
with an
telling.
angle minus
So
delta.
again I'm telling, if you want to calculate the complex power at this node, okay, this node, then you multiply. This is two node. One node is this one node is this one. At this
So how
point,
to
if you
decide calculate which node?
see, if it is asking in the question, the real power will be always same whether you are calculating here or here.
Okay,
Okay.
okay.
Only
Okay.
reactive power will be different. Why that will be different? Because a reactive element will be there in between.
Okay, okay.
So real losses will not be there here. Here also, if you are
Okay.
calculating the power, so real power
Hmm.
equation will be same. So here you can write, you can do one thing, you can write both equation. Here also you write both equation, and here also PQ. PQ you calculate here, and PQ you calculate here. So some reactive losses will be there. So that loss will be I square into X. Okay. That you can.
Sir, so in node 1 we have to calculate V with an angle 0, and in node 2 we have to calculate
Yes.
EZ with an minus delta.
Yes, yes, yes. Whatever the node will be there, in that node, what is the current is flowing and what is the voltage, that will be the considered. So what is the complex power flowing here? That will be E angle minus delta into I. I will be same here and here it will be same. But here the voltage will
Same.
be V angle 0. Okay. So
Okay.
complex power you can calculate at both the nodes, and you can see that the real power will be same. Okay, but reactive power will be different. So Q1 minus Q2 if you will do something, so then this reactive loss you can calculate.
Okay, okay, okay.
Is it clear? Similar kind of
Uh,
questions are already there asked in the gate. Like,
yes, sir. That's why I'm asking, which is very
see, main thing is
confusing.
point. With respect to point, if you are calculating here, it will.
Sir, so Q1 will be with an angle V with an angle 0, and Q2 is equal to EG with an minus delta.
So here
And then we
S
and
will
then we
see
when
S1 will
we
be
subtract.
S1 will be V angle 0 into
I
I
conjugate.
conjugate. S2 will
Okay.
be E
EG
angle
with
minus
an
delta I conjugate.
I conjugate.
So these 2 points you will get, but real power will be
And
same at.
okay, and the difference is the losses in the inductor.
Yes, difference will be reactive losses.
Okay.
The reactive losses also will
Okay.
be I square into X.
Yes, sir.
Okay.
In power system there is a question.
Okay, okay. I will explain that type of question also in next class. So
Okay.
similar kind of more question, if you want, I will bring this kind of question like
Yes. So these
more
types of question are more
get
confusing.
whatever the questions are there in previous year gate. Similar this kind
Uh,
of question I will bring in the next class.
Okay,
So
okay,
like
yes,
real
sir.
power and reactive power, all confusion will be
Yes,
clear.
sir,
S
yes,
is
sir.
equal to VI
Okay,
conjugate. On the
yes,
basis
sir.
of this, I will bring some 4 or
Yes,
5 question whatever there in the gate, or maybe I'll
okay.
prepare some question by myself also, different
Okay, yes,
like,
sir, yes, sir.
so that I will discuss in the next class.
Okay.
Okay. Okay. So this is easy question only. This you can calculate. So in this question, what we have to do, just only we have to we can calculate the EMF by this one. So this here we will put V phase. Okay. Here will be V phase. So what we will calculate E phase. E phase. It will give E phase. But what is the asking the question? What is the RMS value of line to line? So if we will put this value in, it will be wrong.
Into root 3.
What will
Into root 3, sir.
into root 3? So this type of common mistakes generally students will do. While writing the test series, you will improve these things. Like if you are repeating same kind of mistake, you can write in your notes like this type of mistake should not be repeated. Okay. So this question you can
Hello,
solve.
sir.
Yes, you can ask.
Sir, in synchronous problem, we will always put the phase value of terminal voltage
Yes.
in formulas.
Yes. Why? Because this calculation KBL we can write in phase only. Like machines will be like this. Okay, this is a star connection. This is a star connection, but this is line to line voltage. But where we are doing calculation we can do in phase only. KVL we can write here. This is V phase with respect to neutral. So in this line only we are writing the KVL. That's why we are changing that to the phase voltage. Okay, but in delta connection that will be the same phase and line. So in then delta connection no need to change the phase to line. So first in synchronous machine question, first we will check star or delta. If it will be a star, change the line to phase. In delta we can use the same value. Is it clear? So I'm moving to the next question. One delta connected question is there, so that is very good question. I will explain that with some short method. Most of the question bank, if you'll see previous year question bank of all the available materials, then they have solved that in very long method. Okay, I will discuss that with short method. So should I move to the next question? This you can solve. This is easy only. Calculate the E into root 3.
Okay, okay.
Okay, so moving to the next question. So this question is asking, I think 2017. Okay. So delta connection, three-phase cylindrical rotor synchronous generator is there. Okay. Requires a field current of 5 ampere to maintain rated armature current under short circuit condition, and for the same field current, the open circuit voltage is 360. Okay. So what is the rated voltage here? 400 volt.
60.
Rated voltage is 400, but with 5 ampere of current we are getting. So one formula is there. SCR, all of you know, short circuit ratio.
Yes, sir.
So what is this formula? Can anyone tell?
1x per unit.
IF for V rated divided by IF for I rated.
I rated.
And what will be XPU? XP per unit reactance will be 1 by SCR.
SCR.
Yeah, 1 by SCR.
Okay. So this kind of question, if this kind of question will be given, we can easily solve by converting all the data into per unit. Okay. If we will solve by basic method, then what we have to do? First we have to calculate the current, phase current. S is equal to 3 VI, root 3 VI. From here we will calculate the phase current, then reactance in actual value. So actual value will be a very big value. That big value calculation will be very difficult. So we can convert into the per unit and easily we can solve. Okay. So see this 360 degree for 5 ampere. So 5 ampere is producing 360 volt. Okay. So for 400 volt, how much is required? 400 is equal to 400 by 360 into 5.
5.55.
Is it correct? Like how much current, field current is required for 400 volt?
5.55.
Okay. So it will be 5 by 0.9, I think. Is it clear? 5 by 0.9.
5.55.
Okay, that will 5.1. So what will be the XPU? XPU will be IF for I rated divided by IF for V rated. Okay. So IF for I rated how much? 5 ampere. So 5 divided by this is 5 by 0.9. So what will be the X per unit? X per unit will be 0.9. So here up to here only.
Yes, sir.
0.19.
Why this 0.9 divide in divide?
See, for what is the formula for SCR? Field current is required for rated voltage to generate rated voltage, and field current is required to generate rated current. So here 5 ampere of field current is generating 360 voltage. So 5 by 0.9 ampere of current will generate the rated voltage of 400 volt. See, if this voltage will be 360 only, 400 only, like if this current is generating 400, then we can say that the value is X is equal to 1 per unit. Okay.
Okay.
But here that field current is generating 360 volts. So 5 ampere of field current is generating 360 volts. So 5 by 0.9 ampere of current is generating the rated voltage. So IF for rated voltage, IF for rated current. So IF for rated current 5, IF for rated voltage 5 by 0.9. So if we'll calculate, the per unit reactance will
Sir,
be.
can you please repeat it? It's very not understood.
Okay. So what is SCR? SCR is equal to this formula, you know,
Yes, sir.
field current required to generate rated voltage,
Okay.
and divided by field current required to generate rated current. So what will be the XPU? XP will be 1 by SCR. So it will be field current required to generate rated current. This will go at top and this will go at bottom. So field current for I rated and field current for V rated. Okay. So field current for I rated already we know 5 ampere. And field current to generate 360 volt is 5 ampere. So field current to generate, this side I have calculated, field current to generate rated voltage 400 volt. This is the rated voltage. Okay. So field current required to just simple ratio multiply. So field current required to generate 400 is equal to 5 by 360 into 400. So it will be 5 by 0.9. So this value I have calculated.
Okay, sir.
This already we know.
Okay.
So per unit, how much it will be? 0.9. Okay. So what will be the E value? That same formula we can write. E is equal to, here how much? Like see, rated by V is rated. Rated terminal voltage. So V will be 1 pu. Okay. So and resistance is 0. So R will be 0. And this is synchronous generator. Okay. So V plus V cos phi plus IARA whole square plus V sin phi. Okay. And this will be leading. So leading will be minus IA
access.
whole square. So simple calculation will be there. V how much? 1. Cos phi how much? 0.8. Okay. So 0.8 and this RA will be 0. So 0.8 whole square plus V sin phi how much? 0.6. 0.6 and minus this IA excess. IA is how much? Rated. So 0.6 minus 0.9. Excess how much? 0.9 whole square. So it will be 0.8 square plus 0.3 square. This will be value of the E. And what is the value of V? Hello?
Yes, sir.
V will be 1 per unit. So I'm going to calculate this one.
0.85. E equal to 0.85.
0.8 square. 1 second. 8 square plus 1 second. Square plus 0.3 square. How much? This one. Under root this one. 0.85. Okay. So this is E. E minus V into divided by V1 only into 100. How much? Minus 14.55. You can check the answer also. Previous year questions. It will be minus 14.55%. Is it clear to all?
Yes, sir.
Okay. So should I solve some more question or we can take it in the next class? What is the time now? Anyone tell?
Correct.
7:59.
Okay. So I think it will exceed. It will. Some more questions are there, but no.
Please send those questions in the group. We can solve.
Okay. So this PDF I will share. So this session I have taken previous year question only. Okay.
And the new question you are telling, please send that PDF in the group.
Okay. Whatever new question I will frame, whatever the classes I am taking, so that PDF I am already forwarding in the group. Okay.
The new question what you are
Control system, sir.
Yes.
Sir, is there any group? WhatsApp
Control
group
system subject, sir.
or Google Drive?
Yes.
Sir, which kind of group? Sir, WhatsApp group or
WhatsApp group only. You can share your detail in the. Actually, my mobile is off. Next class you can share your number. Okay. In chat box I will add it in next class.
Hello, sir.
okay,
Hello, sir.
Yes.
Sir, next class can you tell control system, sir?
See, everyone will have different. Na? So other persons are also teaching the control system. I think other TAs are teaching like my.
No, till now not started, sir. Not.
Okay. What are going in other sessions? Are you joining that sessions?
Yes, sir. Yes, sir. Other
Yes, sir.
sessions
Sir,
also.
other session have only theory, not
See,
this type of numerical.
okay.
Other
Means most
sessions
of
also
the
started in missions, sir. In Friday
Okay, so
session only
what my
missions, sir.
plan is,
Pure
like,
missions.
see, control system is a very easy subject that you can refer any like that is not very tough questions will be there. So what my plan is, where students are lagging, like where they are facing problem, that portions I am only picking up some questions and I'm explaining. Okay,
Okay, sir.
this is my control system is some questions I can take if you will tell like some particular area, like some, let's say like route Hurwitz criteria, some variety of question you want to see, like some like that kind of thing I can do. But whole theory I explaining in this 1
Okay,
hour
okay,
session.
sir. If possible, you took some important questions
Ah,
and
yes,
short
yes, yes,
minutes, sir.
yes, 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 like
Till
that
now,
I will.
not yet started, sir.
Okay, okay.
That's
So what I will suggest you, so many like already materials are there already. Okay, and NPTEL Ramakrishna sir lectures are there. So that like very good. If you will follow that lectures, that will be very helpful. So first you should go
and
through
sir,
those
sir,
lectures.
one more thing, sir.
Yes, yes.
Sir, how's the lecture of Santanu Kapat?
That is very good. Like power electronics, if you want to go for research in the area of power electronics, okay, like your target is masters in power electronics, then for MS interview that will be very helpful. Like if you are, let's say you are getting rank of 2000, okay, 2000 or 2500, with that rank also you can get top IITs like IIT Delhi, Madras, Bombay. If you are good in that like basics of, like if you go through that those lectures, then you can answer the questions asked by professors. Okay, so that will increase your selection chance for the MS in higher, like IIT Bombay, ISC Bangalore also. That will be beneficial in that way, not for basic gate. Is it clear?
Sir, hello, sir.
Yes.
Sir, the course of power electronic is available for NPTEL in NPTEL.
Oh, NPTEL, like it is by L. Umanand sir, one fundamental power electronics course is there. ISC Bangalore. You can search.
The fundamental and a particular
So many
uh,
power electronics
power
courses are,
electronic.
advanced level courses are also there, like for research level courses, basic courses, all are there.
Sir, how in basic no means for some higher, which one is Santanu Kapat?
That is very good. Another one is like IIT Guwahati, one ma'am is there.
What is
Sabrinath, I think. Professor Sabrinath.
okay.
So that
L. Umanand sir, IC Bangalore is
that is also you should you should
different from that. It is only designing about the designing all the things.
yes, yes, yes. So what is your plan in power electronics? Like what you want to learn?
Like what message you
Sir,
sir?
from basic like inverter or dole converters, like thyristor, I think all the theories completed there.
I think like we have other lectures are also there. We have to search. So many power electronics lectures are there. Okay, we have to see. First, you should, if you want to fundamental, then you should go through that. That sir has taught simulation also, like LTS spice. There you can learn LTS spice. But for gate specific, like that will be more advanced. Okay, I'll
Sir,
some yes, you can ask.
sir,
Hello.
for gate purpose, I want to take.
Power electronics. I will search and tell you in the next class. Okay. So many are there. I will figure it out. What are the relevant? That I will post the link in the next class.
Yes, sir, sure, sir.
Okay. Okay. So thank you all. In next class, I will bring some like VI conjugate based questions. Okay. But today one person has asked that kind of different questions I will bring, and other good questions also I will bring in that class. Maybe some synchronous machine based questions also, or power electronics based questions also I will bring. Okay. Thank you all.
Okay, sir. Bye, sir.
Thank you.
Thank you, sir.
Okay, sir. Okay.